couple of things to take note of as we start standard form, besides the fact that a calculator can be helpful, but not necessary for this. I'll talk more about the assignment part at the end, but up here at the top, we're going to be skipping 48. 45 and 46 we're going to be graphing only, but we're going to be discussing that as well as we get into this. So we're going to do some compare and contrast today with what we've been working on, vertex form of a quadratic, and now what we're going to start on, which is called the standard form, which is going to look like this. Little different from what we've been doing. Okay, so ax squared plus bx plus c. But the main part we're going to be interested in are the a and b values for right now. But they still, even though this looks different than the vertex form that we've been doing, still is going to make a parabola, still is going to make one of those U shapes. Our axis of symmetry, if you remember before, was the x value of our vertex. Still is. How we find it is going to be a little bit different, though. There's going to be this little mini formula that we've got to use. And that little mini formula is negative b, or the opposite of b, over 2a. Okay, that's going to be our key to being able to get these situated when we're dealing with a standard function quadratic. So, when I'm looking for the vertex, again, not a surprise, I use that same little mini formula, negative b over 2a. However, when I want to get the y value, now that's going to be a little more interesting. I can't just take it from the equation like we did with the vertex form. The y coordinate is going to be, when we plug the x equals value into the function. If it doesn't move around, that's going to be 0. But we can't make that assumption every time. So the y-intercept then, and we'll talk a little bit more about that as we go, will be 0 and then our c value. Okay, so c does take a little piece in this, but not a whole lot of one when it comes to trying to deal with that. So, okay, how does this work? Let's jump in and do one and kind of see how this goes. So what is the graph of y equals 2x squared minus 8x plus 5? Okay. First things first. We're going to find the equation of the axis of symmetry, which again is the same thing as the x-coordinate of my vertex. So that negative b over 2a, here's my a, here's my b, here's my c. So to find that x value, I'm going to take the opposite of b. So the opposite of negative 8 is 8 over 2 times my a value, which is 2. So 2 times 2 is 4. And 8 divided by 4 is 2. Okay, so that is my axis of symmetry. That's my x value of my vertex. Now, there's one thing, even with this, as simple of a equation as that is, there's still a little bit of a dilemma here we've got to watch out for. And that is, if we get a little too calculator dependent, even if we plug all the stuff in right, we can get ourselves into some trouble. And I want to show you that here quick. Because a lot of people do this, and I'm like, okay, you can do that in your head. They're like, no, I want to use the calculator. Okay, here's where I can get into trouble. That's what I have here, right? 8 divided by 2 times 2. 8 divided by 2 times 2. Well, why did I get a different, why does that say 8? Harty, did you mess up again? You do that on a regular basis. No. The calculator goes in order. The calculator did 8 divided by 2 and then multiplied by 2. That's not what I want. So what I would suggest doing is multiplying those two numbers on the bottom together first if you're going to feel the need to go to the calculator, and then do your division so you get the right answer. Don't take the lazy way out and then go, oh, really? So what we're going to do, now that we know the x value is 2, we're going to take our equation here, and everywhere you see an x, we're going to replace it with a 2. So 2 times 2 squared minus 8 times 2 plus 5. Now, I have no issue if you want to plug that into the calculator. Okay, I'm not going to yell at you. Okay, I get -3. So my vertex is at 2, -3. And my y-intercept, in this case, is just my c value. But let me show you on this first one where that comes from. Okay, so we don't have confusion with that. When you have a y-intercept, that occurs when x equals 0. So if I wanted to double check sometime, or if I forgot, this is my backup plan. So I can always plug in 0 wherever there's an x. So 0 squared is 0. It makes this whole thing 0. 8 times 0 is 0 plus 5. That's where it's coming from. So you always have that backup plan. Because sometimes we don't remember those little detail things like c is going to be my y-intercept in that case. Just something to ponder. So here, I've got my vertex at 2, -3. Because A is positive, it's 2. My graph opens up. That's normal. That's been the way before. And the vertex is at the bottom of my graph. It's a minimum. So then what I could do is I could plot the y-intercept, but that's normally not how we roll with these. Here's what we normally do. And this was true last week. It's going to be true again now. It's much safer to take your vertex, stick that in the middle of a little mini chart. Doesn't take that long. And when we build our chart with our vertex in the middle, we -1 as we go to the left. We add 1 as we go to the right. Okay. -1 as I go left. Add 1 as I go right. And again, we do that because that way we're going to get the symmetry that we're looking for. And if you remember a second back to last week when we were doing vertex form, we found out these two values to be the same, and so with these two. And that's going to be the same thing here. So how do I get those numbers? I have choices. I can either, if I have access to a graphing calculator, and again, I've said before, Google Play, App Store, free graphing calc, type it in, that they all will get you at least this part, okay, to be able to do that. Some of you even talked to me before about WabbitEmu, which I thought had disappeared off of Google Play, but it has reappeared, okay, as an option. That's an awesome one, because it's basically more like these calculators. But I digress. So here, if I type my equation in, get that in there, I can look at the chart, and just like before, if I get my vertex in the middle, I should see symmetry above and below. Okay? If it's a whole number vertex, and we'll get to how to deal with that too. So -1 and -1, and 5 and 5. Okay? That works. 0, 5, 1, -1, 3, -1, 4, 5. And again, I could even do that if I didn't have access to a graphing calculator. Okay, if it was just my brain or I just had a regular scientific, the only difference would be is I'd take my equation up there and I would just plug the number in where the blank is at. So like here, I just would type in 3's where the x's are. Okay, I still get the -1, and I'd know it was that answer too. I wouldn't have to do that all. And I'd do the same thing with my 4 and my 0. So not that big of a deal. Domain and range. Again, domain is the easy part with all this. Even in standard form, domain's not going to change. It's going to go forever left as it stretches out, forever right as it stretches out. But my range will always connect from my minimum value. Okay? So my vertex, that y value, is always going to be connected to my range. So when we speak of all these things, there's all these connections. Because the word minimum and maximum is going to start coming up. My minimum or my maximum and my vertex are one and the same. And we'll talk about that a little bit as we go. Now, we're going to do one of these down at the bottom. This isn't something I normally promote because I think it actually makes this harder, and I'm not into making things harder. Write each function in standard form. Now, if we were looking to graph, I have no idea why anybody would want to multiply this out. Because I can already get my vertex, and I can start my chart that way, and it makes life a lot easier. So, we'll still see how to do it once. So we're going to have to FOIL this part out. And it doesn't just mean I distribute the squared to the 3 and to the x. I wish it were that simple, but it's not. So what we're going to do is we're going to go to the side here. We're going to make a little box. Because this x plus 3 being squared means we have two of these. So I have an x plus 3 here and an x plus 3 here. And what I do is I'm going to multiply what's on the sides of the boxes together. So x times x is x squared. X times 3 is 3x. 3 times x is also 3x. And I like to put my signs on there just to remind me. And 3 times 3 is 9. So, once I do that, and I go to combine my terms that are alike, I'm not multiplying anymore. When we combine like terms, we're just adding and subtracting. So 3 plus 3 is 6x plus 9. So what's that mean? It means my equation over here is x squared plus 6x plus 9. But don't forget, there already was a part of the equation there, the plus 4. So my last job now to get this finished into standard form is to combine those like terms. Okay, so if I had this equation, or if I had this one, and I went to graph them in the graphing calculator or did the chart myself, I'd get the exact same graph out of that. Okay, so I like to let you see those things, but again, that's not something I'm going to tell you to do, because again, it doesn't make sense if it's in an easier form to put it into a more difficult form to graph it. Yeah, not a lot of sense, but just kind of as an FYI. Because our main focus as we do these is going to be to keep working on the graph part. Now, part of making graphing easier is understanding the parts a little bit more. So we're not going to do any graphing on the back here. We're just going to strictly look at what's the form, how do I do it, what are the parts and what do they do for me. So the first thing here up at the top is something we've talked about before. When I look at my number in front, my a, that tells me if it's positive, if it's greater than 0, my parabola is going to open up. If it's negative, if it's less than 0, my parabola is going to open down. So that's one thing I'm always going to know right off the bat. So when I start to look through these a bit, and we'll kind of look at both sections here. Which function is written in standard form? The one that doesn't have the parentheses. Okay, those are the types of little things that we look for to see, how am I going to tackle this? Which one has an x coordinate of -5? Some of you have issues with that sometimes. We flip the x and y value around, but we can't do that. It's kind of important that we don't. So something to watch out for. Which one has a y-intercept of 2? Now some of you may go, well, wait a minute. My last value here is 2 on both of these. Now that's true. But this is only true in standard form. So it would have to be the second one. Because in the first one, that's my vertex value, that 2. Okay, my y value of the vertex. And then which one opens down? Look at your a values. If if it's negative. Whoops, I almost lost a piece of it. Okay, it opens downward. Those types of little clues at the start of problems will help you to make sure that your graph is being graphed correctly. And use this sheet as a reference. I mean, it says reference sheet right at the top. Use that as you're doing these for a while and be like, okay, oh yeah, that's what goes on with this. That's right. And then vertex form, like what we were doing before, a little bit last week. If I can get that arrow out of the way. Okay, vertex form has the parentheses. Simplest way to remember it. Okay. Which one can I get the vertex form from right away? Well, this is called vertex form for a reason. Because I can take the vertex straight from the problem when the parentheses are there. And again, which one opens upward? Even in vertex form, I'm looking at the A values. And if it says upward, it means it has to be positive. So I get that set. I get that checked out. So again, nothing too terribly awful. So, let's graph a couple of these. Kind of see how this works. So as we go to this next page, we're going to go past the right and standard form. We're going to come straight down to number 4. We're going to do a couple of these, and I'm going to do a couple of the homework ones with you, like we've done before, just so we can kind of put all this together and see how this works. So here, it says graph the parabola, label the vertex, label the y-intercept, label the axis of symmetry. Okay. We're going to add a couple of things to this. We're going to label the min or max. And we're going to tell what the range is, because we know what the domain already is going to be. The domain is always going to be negative infinity to infinity. That's really not a big deal. But the range can be. So let's see here. Let's try out, well, let's just start with 4. That's a good spot to be. Okay, questions here at the start. First, is number 4 going to open up or down? Look at your A value. Are we going to be having an up parabola or a down one? Down. Okay, my A value is -3, so it's going to be down. Now, if I need to sneak a peek a little bit sometimes, it's okay to look back, especially at the start here. Okay, my first job is to find my vertex. So, I'm going to use my little mini formula here to figure that part out. So, I've got to do a little calculating. So, x is going to be the opposite of b. The opposite of 6 is -6. Over 2 times a. So again, plug that in your calculator, use your brain, whatever you think is going to get you to the best spot. Get my x value. But again, I still need to know what y is. So to get y, remember, I'm just plugging that 1 in for the x's here. So whether I do that in the calculator, or whether I just kind of do it by hand, especially with 1, I think I can probably handle it. So 1 squared would be 1 times -3 would be -3. 6 times 1 is 6. Minus 2. And I get that all put together. And I get 1. So my vertex is at 1, 1. Now at this point, I've got choices on how I take this on. One way I can do it is by doing the chart like we've been doing for a while. I put my vertex in the middle. I add 1 as I go to the right. I minus 1 as I go to the left. So I could get that set up. And so now, remembering that these two are going to get me the same answer and these two are going to, I've got options. If I have the option and I can plug this into the calculator, that's not a bad idea. I could look at the chart. I could make sure. I'm like, okay, there's my vertex. So it looks like these are both going to be -2. And again, otherwise I could just plug it into the equation if I didn't have this option. The other ones are -11. Now, if I have a graphing issue with that, as long as I have 3 points, I'm still okay. So, 2, -2. I can get that graphed in. So you're like, okay, what have we got done here? We got the vertex. Okay, there's my vertex. My axis of symmetry is always going to be x equals and whatever the x value of my vertex is. There's that connection. My y-intercept is always going to be 0 in my c value, or I can plug in 0 for x. Y-intercept, axis of symmetry, got that, got that. Okay, what's this minimum maximum thing that you're talking about? Okay, when we look at our graphs, there's either going to be a point way, way, way at the top, which we call a maximum. You're on top of the world. Or if it opens up, there's going to be a point way, way, way at the bottom, which is called a minimum. But here's the cool thing. Your vertex is always going to cover you on this. So here, my maximum is the same number as my vertex, because it's the value that's at the top of my graph. And that's going to come into play when we start doing the application stuff a little later in the week. And finally, you're like, not we haven't done enough, is going to be my range. My range always applies to my vertex as well. It goes down forever, so I start with -infinity. But it doesn't go up forever. It goes up as high as, no coincidence, 1. Look at all the connections that are going on with these. So it's kind of a slick way of going about it. Now I want to look at one more, because again, we always like to see what things can start to happen. Make sure we're all right. So I look down here at number 6, and I go, okay. Start getting my information here. And the cool thing, I can use what I've got up here kind of as my guide. So I got my A, my B, and my C. Always first best thing, most important thing to do, start working on that vertex. You're going to be over 2A. So the opposite of -8 is 8. Times 2a. 2 times 2 is 4. So the x value of my vertex is 2. Now I'm going to plug that 2 in for both of these x's. And again, if you want to go to the calculator, you are more than free. Just make sure you type it in carefully. I'm just going to use my brain. 2 squared is 4, times 2 is 8. 8 times 2 is 16. Ooh, that's a doozy. It does fit to -11. Get that first point. Once I have that again, and I'm going to show you one other thing after this one that I haven't yet. And it may be one of those things. Sometimes some of these things work great for some of you. Sometimes you're like, just let me keep doing the same thing. And I'm like, all right. Vertex in the middle. +1 as I go to the right. -1 as I go to the left. Whoops. Let's keep that same color. -1, +1. And again, I start to plug values in. So if I don't have the chart, we'll pretend that we do not have a graphing calculator. So let's say I decide, okay, I'm going to use 3. Plug 3 in there. Okay, so that'd be -9, -9. And then again, these are going to be the same as well. It doesn't matter which one I plug in. Now, to me, 0 makes the most sense because I could probably do that in my head, but I already just jumped in here, so. And get those values plugged in. So once I have them, get those in there. We'll get our graph made. And then I can kind of start going down my checklist of to-do items. Got my vertex. My y-intercept. 0, that'll be the x value every time, and whatever my c is. Good there. My axis of symmetry. Always the x value. Always the one that's in my vertex. Maybe even drawing it in might help that stick a little better. The min or the max. This time my vertex is at the bottom. We're at the bottom, we're at our lowest point, we're at our minimum. It's just the same thing in there. And then finally my range. This one goes up, up, up forever. So that'd be positive infinity. And just like every other time, y value here, direct connection to where my min or max is going to be. And I'm set. So before I move to doing a couple of the homework ones with you, I did want to show you one thing. There is a pattern, this happens a lot in math, that you can actually use to do your graphing if you don't want to use the chart or the calculator. Here's how the little pattern works. And I'll show this on something else we're going to do too. I call it the +1 +3 pattern, and here's how it normally works. When you're going to graph, as you start from the vertex, if you just had y equals x squared, take your vertex, you go up 1 and over 1 each way, then you go up 3 and over 1 each way. If there's a number in front, though, okay, you multiply these by the a value. So in other words, this first one, instead of +1, 1 times -3 is -3. I minus 3 going each way. 3 times -3 is -9. I minus 9 going each way. And I could do a pattern. Now for some of you, that's not going to work. For some of you it is. Same thing here. 1 times 2 is 2. Added 2, added 2. 3 times 2 is 6. Added 6, added 6. And sometimes people even just do it right on the graph and they don't even worry about making a chart. It's an option. Maybe an option for you, may not be. I'm going to discuss it again here in a minute as we get into a couple of the homework problems, which I probably should go find a piece of graph paper if I actually want to do this. So let me grab one quick. Like I'd mentioned before, when we were jotting these down, so we got 9, 10, 13, 14, 45, and 46. We're not going to do 48. (45) and 46 we're going to graph only. Otherwise, we're going to follow the directions that are in the book. And probably should show you what directions the book are. I'm going to ask you to do that. So basically what we're going to be doing in the book is the exact same thing that we've been doing working through these examples. So when I peek in the book, maybe, like, oh, Harty gracious. Maybe I can put it down. There we go. Identify the vertex, the axis of symmetry, the min or the max, and the range of the parabola. So, if I move this a little bit, you might actually be able to see all the problems that you need. Pause, pause, pause. You can hit pause on me at home if you want to. So, we're going to take a peek at 13. So I'm going to go, for those of you that don't like going out of order, move down a little bit here. We go to the third graph down. If you don't mind order or not, you're not going to worry too much about it. And here's the reason I want to do this one. I think the examples you have already will do you very well for the first couple of problems. 13 is going to cause an issue, and I want to make sure that we tackle this right away so we're not freaking out about it. So I get to 13 and I go, all right, A, B, C. So what do? I go to do my x value first, to my vertex. Opposite of B over to A. And I plug this in the calculator, and at first I think I may have done something wrong. Because I'm like, okay, 2 times negative 2 is negative 4. 3 divided by negative 4, I got a decimal. That can't be right. We don't get decimals. You can get decimals. So negative 0.75. No worries. This is why we do things to give ourselves options. So I got to make sure I'm careful this time. So I got decimals, I got negatives. Lots of little things that could mess this up if I'm not cautious. That's kind of nasty. No worries. So I get that part done. And I go, okay, so what does that mean? That means my vertex is at a really funky number. I mean, that's just weird. So let's, okay. So I put my dot in there. So then some of you are kind of curious. You're like, well, how am I supposed to do this now? Because now this is a decimal. If I do have a graphing calculator, and I try to put this in y equals, type it in, I pull up my graph, but wait a minute, there's no decimals in here. I'm not going to see symmetry. Can I just start plotting random points and make some funky looking graph? No. If you get into that dilemma, here's what I suggest. We're still going to do this exactly like we did before. You're like, but wait a minute, there's decimals, there's fractions. Okay? No big deal. Negative 0.75. What do I do as I go to the left? I minus 1. Okay. It's going to be a decimal. I have a calculator. When I go to the right, what do? I add 1. It's going to be a decimal. That's okay. And I'm going to keep doing that. Add 1 to the right. Minus 1 to the left. So there's 2 ways I'm going to be able to tackle this now. You're like, why is there 2 ways to everything? Well, to me, it's nice. It's flexibility, but everybody's got their own way. I can either take my equation, plug my values in, just like we do when it's any whole number. I'm just going to mention, though, it's not a coincidence that these are each down 2. Because, again, 1 times negative 2 is negative 2. Just saying. And then if I do it one more time with my other value, again, making sure I'm typing in carefully, that what I'm doing right now could be done with any scientific calculator. But I want to show you one other trick if you do have the graphing calculator. You're like, well, the graphing calculator is kind of worthless with decimals. No. Check this out. So I had it typed in before, right? If I look at the graph, there's one more function I can pull, and some of you are going to love this. If you hit the trace button, okay, I can type in any x value I want. Let's say I want to type in 0.25. If I type in 0.25 and hit enter, check this out. It'll tell me the y value. If I want to plug in 1.25, I hit trace. 1.25. It tells me the y value. So the chart won't help me on the decimals, but just hitting that trace button and plugging in the x value will tell me what y is. That's pretty slick. So now that I've kind of seen that, I'm like, okay, this isn't quite so bad. I just used the regular old equation that I've got here at the start of my problem in my y equals. And then once I hit graph, and I have the graph there, if I hit trace, I can plug in any x value I want. So if I've made my chart, I can knock it out that way. And so then it's basically just becoming, all right, I need, and it won't be perfect, and I'm not expecting it's going to be, but I'm going to sort of just guesstimate, let me move this back over here a little, about where all my points are going to be. A little past 1, less than -3. Get my graph in. Okay, and decimals won't happen a lot, but they will happen some, like you're seeing here. So you're like, okay, what do I still need to do? What did he say? I don't even remember at this point. All right, got the vertex. Axis of symmetry. X value of my vertex. Okay, my max or my min. It's at the top. It's a max. Howdy.
Is this on?
Nope.
Can you give those to
Sure can.
Thank you.
Absolutely. Not a problem. Always good when we can talk mathematics. And then the range. My range, again, if it goes down forever, starts at -infinity. And where's my top point? It's right here. So if it's standard form, that's the way I work. If it's vertex form, keep doing it the way that we were doing it last week. Okay, use that chart and work it through. Tomorrow, we'll be doing some more of these. Okay, we're going to have some more time to chat in class. We're going to have more time to talk about that little chart thing that I've drawn over there on the right side of the board. Okay, or your left maybe. But do try some of these. Maybe take a picture of the key. Check some answers, do some things. If you sit and don't do anything, it also just like puff smoke.